All right, let's dive right in. Imagine this, you're an AI developer managing tight budgets, and suddenly Google drops a bombshell announcement on May 8th of this year, a new feature called implicit caching for their Gemini API.
Ooh, sounds fancy already. Go on.
It totally is. So this feature is designed to slash costs for developers using Google's AI models. And here's the kicker, it's automatic. That means no extra setup or configuration headaches.
Automatic? Okay, now that's music to my ears. What models are we talking about?
It's specifically for their Gemini 2.5 Pro and Flash models. And get this, Google claims it can save developers up to 75% on costs when dealing with repetitive content.
All right, 75%? I mean, I like saving as much as the next person, but 75? That's a leap. What's the fine print, Zach?
I hear you, but that's exactly what makes this feature impressive. No strings attached on the setup side, it's just enabled by default ready to go. It's a complete shift from their explicit caching system from before.
Explicit caching. I remember that. Let's be real. It sounded good in theory, but who had time to manually define every single prompt?
Exactly. Developers found it too tedious, which often led to them skipping it entirely. Implicit caching, on the other hand, steps into that gap by automating the whole process. The system recognizes repetitive content and makes it seamless to start saving.
Okay, I'm intrigued. How does it decide what content counts as repetitive, though? Or are we getting ahead of ourselves?
No, you're right on point. Let's break it down. The system detects repetitive content by analyzing the requests developers send to the Gemini 2.5 models. If a new request begins with the same prefix as a prior one, boom, it reuses part of the computational results from before.
Wait, hold on. Are we talking recycled content here?
Not exactly. It's like recycling effort, not content. The model still processes the task fully. It just skips duplicating steps it's already done. Picture this. You're running AI requests with some repetitive opening steps. The system recognizes that pattern and saves you from paying for the same computation twice.
Okay, that makes sense. So it's all about spotting patterns. Is this algorithmic magic?
That's one way to put it. Google calls it implicit caching because you don't have to do anything fancy to enable it. It just kicks in automatically for repetitive content.
All right, automatic sounds awesome, but 75% savings? I'm still stuck on that. How does it hit such a high number?
Well, a big chunk of the savings comes from avoiding redundant processing on larger repetitive text blocks. For example, if you have similar prompts that only tweak details near the end.
Like variable data or something?
Exactly. By putting repetitive content at the start and dynamic parts at the end, you're giving the system a clear chance to reuse prior computations. That's how developers can really maximize these savings.
Got it. And how picky is it with what it considers repetitive? Like, does your request have to be an exact copy?
Not an exact copy, but it does rely on the request's prefix, which is basically the first segment of text. If that prefix matches a recent request and it meets the token threshold, 1024 for Flash or 2048 for Pro, the caching magic happens.
Token thresholds. Sounds technical, but manageable. So, let me guess. They're handing developers some tips/rules to make the most of this feature, right?
Exactly. And speaking of how they've optimized this, before the days of implicit caching, Google relied on something they called explicit caching. Let me explain how that worked.
Simple in name, sure, but I remember developers really didn't love it. What was the deal?
Well, the idea was solid. Developers had to manually define their most commonly used prompts. Theoretically, it could save on costs, but
But manually. Ugh, that sounds like a nightmare.
exactly, it was tedious and honestly kind of impractical for most developers. A lot of them just skipped it entirely because of how much extra work it added.
So instead of saving time, it piled on more effort?
Pretty much. But that's what makes implicit caching such a game changer. It removes all that manual setup. The system now automatically identifies repetitive content and handles everything behind the scenes.
Okay, I'm following. Automating this sounds way better. But how exactly does it lower the barriers for developers? What changed?
Well, the trick is the automation itself. It recognizes patterns in the request, things like recurring phrases or structure, and applies caching without any additional configuration. So now, developers don't need to learn or remember anything extra.
Oh man, that's night and day. No extra learning curve, no setup, just savings?
That's the vision. The idea is to make it accessible for everyone, from big companies to solo developers trying to keep costs down.
Right, so they've ditched the manual grind and made it seamless. I gotta say, I'm impressed. Is there a catch? Like, does this automation come with trade-offs?
Well, that's the thing. There don't appear to be any big trade-offs, at least from what Google's shared. The only real effort on the developer's end is learning a few best practices to maximize savings.
Best practices. Okay, let me guess. It has to do with organizing your prompts effectively, right?
Exactly. Things like placing repetitive content at the beginning of your request, keeping dynamic content at the end, and monitoring timing between requests. They're simple tweaks that, honestly, go a long way.
So developers can build smarter prompts and let the system handle the hard part. I gotta admit, it's pretty clever.
Totally. It's a major step forward compared to the older explicit system. It really feels like Google listened to the feedback here. Speaking of how this automation works in practice, let's dive into the technical details. The magic happens when you send a request to Google Gemini's 2.5 models with the same prefix as a previous one.
Wait, by prefix, you mean like the first part of the request?
Exactly. The system checks the opening section of your request. If it matches a recent one, it'll reuse parts of the computation to save time and, more importantly, costs.
Interesting, but let me ask you this. How close does the match need to be? Are we talking identical or…
It's not about an exact match, more like structural similarity. The prefix just needs to be close enough for the system to recognize it as repetitive and hit that cache.
Gotcha. And what about these minimum token things you mentioned? What's going on there?
Great question. So for the system to kick in, there's a minimum token count your request has to meet. For the Gemini 2.5 Flash model, it's 1024 tokens. For the Pro version, it's 2048 tokens.
Okay, but how big are we talking here? Like, are we writing a novel in these prompts?
Not quite. Even medium-sized prompts, like a few well-structured paragraphs, can hit those thresholds. So really, it's not as daunting as it sounds.
All right, I see where this is going. So for developers, hitting these token numbers is kinda the gateway to savings, right?
That's one way to put it. If your request meets the token minimum and matches a prefix from a recent request, congrats, you're now saving on redundant computations.
Okay, that's cool. And this works across both the Flash and Pro models?
Yep, both models support it, but with those slightly different thresholds. Flash is a little more relaxed at 1024 tokens, while Pro has that 2048 token benchmark. It's all designed to encourage smarter usage of their systems.
So it's kind of like giving developers a hidden efficiency tool. You learn how it works and suddenly you're cutting costs like a pro?
Exactly, it's all about understanding how to structure your requests to hit those triggers more often. But we'll get into that next. So, building on that idea, let's dive into strategy. If you're a developer aiming to maximize savings with implicit caching, it really comes down to how you structure your requests.
Okay, I'm curious. What's the secret sauce here?
Three key things. First, and this is crucial, place repetitive content right at the beginning of your requests. It lays the groundwork for a higher cache hit rate.
Repetitive content upfront sounds simple enough. Why does that work?
Because the system relies on the prefix of your request to decide if it's a match. If the repetitive part is right there at the start, it makes the system's job a lot easier.
Gotcha. So no burying the repetitive stuff later in the prompt, huh?
Exactly. And the second tip, append any variable or unique content at the end of your request. That way, you're not breaking the pattern recognition early on.
Huh. So repetitive stuff up front, custom details in the back. It's like structuring a sandwich. Am I stretching here?
Not at all, actually. Think of it like a well-layered sandwich. Keep the base consistent and stack the extras on top. That's how you maximize those savings.
All right, I'm with you so far. What's the third piece of this cache maximizing puzzle?
Timing. Try to send requests with similar prefixes within a short time window. The system's cache is dynamic, so recent matches are more likely to get reused.
Oh, so it's time sensitive too. How short are we talking here?
Think minutes, not hours. The closer the timing, the better your chances of hitting that cache sweet spot.
All right, this is starting to sound like an art form. Structure and timing? Developers have their work cut out for them.
It's not as intimidating as it seems. Once you understand the system, it's just about tweaking your workflow. And hey, the payoff is worth it. Those cost savings can really stack up.
All right, so to recap, start with the repetitive stuff, keep the unique bits at the end, and don't take too long between similar requests. Did I nail it?
You nailed it. And honestly, these small adjustments can make a huge difference, especially if you're running frequent API calls. Knowing how to play the system saves you more than just money. It's efficiency gold.
All right, noted. You'd think running smarter prompts was part of the developer skill set already.
Right? But when the stakes are this high, even little optimizations can feel like game changers. And trust me, with the rising costs of AI models, every edge counts.
Speaking of which, I feel like the cost side of things deserves its own deep dive. Developers are already sweating over price tags.
Exactly, Alex. Costs are a huge hurdle, especially when you're looking at top-tier AI models like Gemini 2.5. These can be game changers, sure, but for startups or independent developers, those price tags can feel impossible to keep up with.
Yeah, and it's not just the cost, Zach, it's the unpredictability too. One wrong prompt, and boom, you're staring at a surprise bill no one budgeted for.
Absolutely. And before implicit caching came into the picture, Google's solution was explicit caching, which, as we've talked about, was a headache in its own right.
Oh, for sure. I mean, explicit caching sounded like a decent idea on paper, but all that manual setup, it kind of missed the point of being user-friendly.
Exactly. I think that's why so many developers ended up avoiding it entirely. It just wasn't practical for fast-paced environments where time and simplicity matter.
And isn't that what makes the implicit system such a big deal? It feels like Google finally listened to all those politely worded complaints from developers.
Haha, exactly. And those complaints weren't minor either. There were even cases of unexpected bills hitting teams that didn't fully understand explicit caching's quirks. Implicit caching really seems like a direct response to that backlash.
Right, and while the idea of a seamless, money-saving feature sounds great, I can't help but feel like there's this wait-and-see vibe in the developer community.
That's fair. Google's promising up to 75% cost savings, but without third-party proof or substantial user feedback, it's all still a question mark.
Yeah, it's like, great concept, but let's see it in action before we start celebrating.
Exactly. Still, even with those uncertainties, if implicit caching can deliver on even half of its claims, it could reshape the way developers think about using advanced AI models, especially for smaller teams that can't afford to take big risks on costs.
Totally, I mean, tools that lower barriers and keep budgets predictable, that's not just helpful, it's kinda essential in today's AI landscape.
No doubt about it. And you have to think, if this works out, it might even push other players in the AI space to launch similar features. A rising tide lifts all boats, right?
Here's hoping. But right now, I think most developers are watching and waiting just to make sure this isn't like too good to be true.
Given all the skepticism we've touched on, let's dive deeper into how caching really fits into the broader AI ecosystem. Why it's not just about flashy cost-saving claims, but also about optimizing performance and driving efficiency where it counts.
You're saying big deal, but how big are we talking here?
Pretty big. Caching is like a backbone in AI applications. Take AI-powered search engines like Google Gemini, or even tools like ChatGPT. They have to pull off real-time responses while keeping costs and latency low. Caching makes sure repetitive calculations aren't slowing things down or wasting resources.
Okay, so it's speed and cost. But how does caching actually help with speed? Like, what's the magic?
Well, it's simple. Instead of recalculating something it already knows, the system can just reuse stored computational results, like hitting a replay button instead of starting from scratch. The result? Faster responses and way less resource intensive.
Got it. But here's what I'm wondering. This isn't just about APIs, right? What about, like, browser-based stuff? Does caching hit there too?
Oh, definitely. Browser-based caching is like the perfect teammate for API caching. Think of Chrome, for example. It's already using caching to store things like request-response pairs in its long-term memory. That works wonders for client-side apps that need snappy performance.
Okay, so we're talking teamwork here. Back-end API caching and front-end browser caching working together?
Exactly. When you combine both, you're creating what's essentially a complete optimization system. It's like you've got two nets to catch unnecessary repetition, cutting time and cost at every level.
All right, and that's huge, especially if your app needs real-time updates or I don't know, you're running something super heavy like,
Like a high traffic AI chatbot or a search engine. Spot on. Real time responses need that balance of speed and accuracy, and caching is key to making it all work efficiently.
right. But I guess what I'm stuck on is that we're just now hearing this buzz about AI caching, and it sounds like it's been, quietly doing this behind the scenes for a while.
That's a great point. Caching has always been around for efficiency, but as AI gets more advanced and, frankly, more expensive, its role is becoming way more visible. Developers are realizing just how much they rely on it to stay competitive.
Yeah, like hidden tech that suddenly decides it wants a little recognition, huh?
Pretty much. But honestly, the fact that we're now seeing features like implicit caching show up, it says a lot about where AI tools are heading. They're not just getting smarter, but also way more practical and accessible at scale. So, building on that, implicit caching isn't just something unique to Google, it's setting a new standard across the industry. With them raising the bar, it feels like cost efficient, accessible AI tools are becoming less of a dream and more of a baseline expectation.
Right. And it's not just the big players who'll benefit from this. I mean, smaller teams and solo developers, they're the ones who really need these kinds of cost-saving features just to stay in the game.
Exactly. And the way this system works, with that focus on automating savings, it kind of shifts the conversation entirely. Developers don't have to jump through hoops to make it work. The heavy lifting is done for them.
Yeah, and that accessibility thing? That's a big deal. It's turning what used to be a niche tool into something anyone can use. No excuses, no headaches.
Totally. Plus, it sets a pretty powerful precedent. If Google's doing this now, you've got to imagine other providers are going to roll out similar features to keep up. We might be seeing the start of a whole new trend in AI optimization.
Right. It's like when streaming services first started introducing offline downloads. Now everybody offers it, and we all just expect it.
Exactly. And here's the thing, we're not just talking about cost savings here. This is about making high powered AI more accessible for everyone, which, let's face it, is kind of the whole point of innovation, isn't it?
Yeah, and honestly, it's kinda exciting to think about where this could lead. Like 50 years from now, we'll probably look back and laugh at how we used to pay full price for redundant computations.
Haha, yeah, no kidding. But seriously, these incremental improvements are what drive the industry forward. It's not just about what's possible today, it's the foundation for what's coming next.
For sure. And on that note, we've covered a lot today. I think it's safe to say implicit caching isn't just a footnote, it's a headline.
Couldn't agree more. And hey, for all the developers out there, remember that even small changes, figuring out how to structure your prompts better, timing your requests, can make a huge difference.
Totally. Smarter prompts, smarter savings. Sounds like a fair trade-off to me.
All right, and that's a wrap from us today. If you're as excited as we are about these developments or have questions, don't hesitate to reach out. We love hearing from you.
Absolutely. And hey, if you enjoyed this episode, go hit that subscribe button. There's plenty more tech talk where this came from.
Thanks for joining us. We'll catch you next time on Zach Talk.